Hi, I'm Tim Berglund with StarTree. Welcome to Pino 101, Architecture, Servers, and Brokers. Now, servers in Pino are, I'm not sure what to call them. I want to call them servers. We'll call them computers that host segments and do most of the query processing. So they are, in a real sense, the true heroes of the cluster. It's where almost all the storage takes place and almost all the query processing. Very, very important components. They're generally segregated into real-time and offline servers. Now, that's an operational convention. A server itself doesn't know whether it's real-time or offline. That's not a thing that you do to the server. But generally, since we have real-time and offline tables, we tend to store all the real-time tables on a set of servers that we call real-time servers, and all of the offline tables on a set of servers that we call offline servers. And that convention makes sense from an operational perspective based on the different kinds of workloads that those two servers carry out. But you'll find that in the documentation and the discussion and just the way Pino clusters are administered. In a previous module, we talked about segments. Go back and review that if you're not sure what segments are. But here I've got just a bunch of segments. These are the segments that comprise a table, or these may be many tables. They're not labeled. They might even belong to different tables. All of these segments, we'll just take away the colors and say, hey, let's give them segment numbers. Those are stored on a server. So it's the server's job to store those segment files. And this is very likely on local SSD, very high performance, locally attached storage. And that coupling of the compute and the storage in the server is key to Pino's performance. And because servers scale out, here we have a gigantic cluster of 2 servers. That would actually be a pretty small Pino cluster. But the point is we can have sort of arbitrarily many servers with our segments in our Pino cluster stored on those servers. Segments are replicated between servers, so we might say store each segment in 2 places. So as you can see, we'll just kind of distribute those between the servers, and each one will be in 2 places at all times. And there's a mechanism in Pino called the controller, which we'll cover in a different module, that makes sure those 2 replicas are kept on 2 servers all the time. A nice thing about this, since segments are immutable, replication is a lot easier to think about. So if you've dealt with other distributed databases that deal with a mutable data model and they're replicating data, well, that gets difficult. You have to figure out which replica is up to date and have some consensus algorithm and all that. Well, you don't need to do that when segments are immutable. You just need to make sure that you've got copies of things because the things are not changing. And it tends to be a lot easier for Pino to be Pino when it comes to replication because of that. Brokers are the other half of query processing. What they do is accept requests from clients, that's a query, and they forward those requests on to the relevant servers, which implies that they have access to metadata that helps them know which servers are relevant for that query. So that query references a table. That table has some number of segments in it. Those segments are stored on certain servers. And so that broker then knows, at least at that top level, which of the servers in the cluster might be involved in processing the query. Now, the broker is also able to be somewhat smart in saying that, well, given the ranges of things in this query, we know we only need to use this server and that server. I only need a couple of segments there, so I'll be smart about how I scatter that query out. There are 2 kinds of queries that a broker might do, and this is configurable at the cluster level and configurable at query time also. There's a single stage query and a multi-stage query. So historically in Pino, single stage was all we had, and what happened there was the broker would scatter the query to the relevant servers. Those queries would do their query processing, like most of that hard work happens, and they send some small result set back to the broker. Again, think of a typical analytics query. Maybe you're filtering over billions of rows, but you're selecting a small number of them with a filter and computing an aggregate. So what comes back from that? That's a scalar, right? That's an average or a count, or it's a number. So the servers just send that number back to the broker, which then runs the commutative associative reducing function over those few numbers that come back, and you get your sum, and it's fine. So the broker didn't have to traffic in a high volume of data. It sent queries and it got some scalars back in that single stage case. Well, to support different kinds of queries, like say joins, there might be lots of records coming back from the first stage of the query. And that poor broker getting, say, millions of rows back for an inner join to figure out which ones match so that it can compute an aggregate over some joined field, well, that might be a lot for the broker to do. It just wouldn't have worked. And so in that case, we've got the multi-stage query engine. We'll cover that in more detail in a separate module in this course. But in that case, the broker is creating a plan, distributing it to servers, and those servers, one of those servers ends up sending the result set back to the source broker in the end. Visually, you can think of that like this. You've got 3 servers, they got a bunch of segments on them. A query comes in to the broker. We're gonna select star from something because we just want to watch the world burn. Hopefully there's a good where clause there. And the broker says, okay, I know this is gonna need segments 2 and 8. So I'll scatter the query to servers 2 and 3, and okay, there's 2 and there's 8, and those servers will do that work, send their results for their part of the query back to the broker, and then the broker can forward that result on to the client. We can't talk about servers and brokers without talking about the deep store. The deep store is permanent storage for segment files. Now, when a server is operating on a segment, when it's doing a query, that segment is stored on the server. You can't reach out to the deep store and do a query there and get the results back. But you can back up a segment into the deep store, and the deep store can in some cases be used as like an intermediate place when you're loading a segment into, say, an offline table. One of your options is for that process, whatever it is that creates that segment file, to actually put it in the deep store and then go tell the cluster, hey, it's there, you can load it into a server. The deep store can be on a local file system, and usually for like quick starts and sort of examples, it's just relegated to the local file system because that's easy. It can also be in HDFS, kind of for legacy purposes, and more commonly in an S3 compatible cloud blob store. That's generally where production deep stores live. Now, this is not some kind of comprehensive Pino backup solution. For example, Zookeeper is present in a Pino cluster, and you'd also have to back up the persistent copy of the Zookeeper database if you wanted to back up the whole state of the cluster. So there are other things that you need to grab besides just the deep store. You don't want to think it's okay, I've got the deep store, everything's good. But it is also a key part of the cluster and something that should be a part of your picture of the architecture. So that's it for Pino, brokers, and servers.